index number. This is basically a count. Okay. Number 3, you're going to compute probability with the formula f sub I equals I minus 0.375 over n plus 0.025. Now, for some reason, I don't really know why, they did not put that formula on your formula sheet. Okay, so that's one that I will give you. If I forget to give you, just ask and I'll give it to you. Okay? Number 4 is find your z-score, which is with norm as inverse. Okay? And then 5 is plot the observed versus the z-scores. We are hoping for a 45-degree line. If we get a 45-degree line, then we're going to say our data are normal. If not, say it's curvy or something else, then not normal. Okay? So let's show you guys how to do that. Okay, so let's say, well, you know what, I won't make it like that. I mean, my last class. If you want to go over to your in-class worksheets, worksheet 7.4, and we will look at that one. Okay? All right, so the following are finish time in seconds for 6 random races for a greyhound dog named Barbie's Bomber in a 5/16 mile race. Is there reason to believe these times are normally distributed? Now, of course, we would love to run the dog to death. Well, actually, we don't want to kill the dog, okay? So we can't just give them a bunch of running things, especially in the same day or something, okay? So the question is, are these data normally distributed? Now, what's the most forgotten step? Sort your data. Are you going to forget that?
Probably.
How do I help you remember to sort your data?
Write it down.
I wrote it down. Okay, don't forget. Should we do this without sorting it and then compare it with sorting it?
No, just sort it.
Okay, just sort it. Okay, because it'll screw it up. If you miss that first step, nothing you're going to do after that's going to work. No matter. Okay. So, how do you sort your data? Nathan, you remember? Sort and filter, smallest to largest, just like that. Okay? All right, so don't forget that step. Step number 2, I'm going to create an index number, okay, which is basically 1, 2, 3, 4, 5, 6. Okay? Basically, you just count it. Okay? Step number 3 is I need to find f sub I, which is basically your probability. Okay? So if this were normally distributed, what we would do is we would say, okay, and use your parentheses on this. You're going to take your index number, 1 in this case, you're going to subtract 0.375, and you're going to divide it by n. What is n, Cooper? No. What is n? N is always your sample size, number of points. So I've got 6 points, so I'm going to divide this by 6.25. Every time that n is not going to change. The I will change, the n will not. Okay? All right, so if this were normally distributed, that would be 10% of the area to the left of 1. Yes?
Wouldn't it be 6 plus 0.025?
Which is 6.25. Right? 6.025. Did I put, oh, you know what? Sorry, that should be 0.25. I wrote that wrong. That's why. Okay, sorry, yes. Good catch there, Cassidy. Okay? All right, so I'm gonna copy that down. Okay? Now I'm gonna find my z-scores. Okay? So the so here's where, this is where it's really easy to get messed up. You're gonna use norm S inverse, not norm S dist, okay? Norm S dist, you take a z-score, you get a probability. Norm S inverse, you take a probability, you get a z-score. So they're just opposite things, okay? So in this case, you can use norm S inverse. I like the one without period, but it doesn't matter. Norm S inverse of that, so I did norm S dist, norm S inverse, okay? Norm S inverse of that is negative 0.128. And if you really want to use norm dot S dot dist, you can use that one as well. It does the exact same thing, okay? Doesn't matter which one you use. These are exactly the same, okay? Oh, except for I put the wrong one again. Inverse, that one matters. Norm S inverse, you do the probability there, it will work. Okay, it doesn't matter which one you use. You're gonna copy that down. Okay. So I've sorted it, I've added my index of QQ, my probability, I found my z-score. Now I need to plot my observed, my times in this case, versus my z-scores. Okay. Insert. Oh, I hate this computer. Does this to me every day. Scatter plot. Okay? So the question is, do you think that looks like a 45-degree line? Yeah, this is off a little bit, but that's pretty close to a 45-degree line. I'd say yeah. Or better yet, let's get this dog to run a few more races, maybe that'll help. Okay? So sometimes it can be tough to tell. Now, let me show you some examples here of some QQ plots. QQ plot. Okay? All right. So as we look at these, well, let's look at that one. What do you think of that one? Does that look like a nice straight line? Yeah, it looks pretty good. How about this one? Kind of curvy on the ends, right? So I'd probably say no, that's not normally distributed. How about this one? No way. How about that one? First one looks kind of okay. A little worried about here. Second one, no way. That's way too curvy, right? How about that one? Yeah, I probably said no on that one. How about that one?
That's kind of a tricky one.
It actually says it's left skewed, so that gives it away, right? Okay. Now, one of the things that I will tell you, oh, how about this one? Way off. Okay? And notice there's a lot more than 30 data points on there. Generally, 30 is kind of the number that we like to use, but it's no guarantee. Okay? So that one looks pretty good. Now, sometimes they have these nice little, they call them confidence intervals. I don't know how, so let's look at this one here. Okay? Now this one's kind of nice. I'll blow it up a little bit. Okay? This one's kind of nice because it has these little red lines and it says basically, if you stay within those dotted red lines, it is. So what do you think? Is that one normally distributed? No, we're outside the lines here and we're outside the lines here. So I would say that one's not. Okay? How about, let's find another one here. How about this one? That one's pretty close, but we've got a couple outside the lines here, we've got a couple outside the lines there, so I would say no.
So
Those lines make it nice, don't they?
So, okay, so all of them have to be.
All of them have to be in there. How about this one? Well, that one's pretty cool. This one looks weird though. Never mind. I don't want that one. I don't have any other good ones. So, oh, this is a good one. What about that one? That one looks very good. Okay? Now, I wish I knew how to create those lines. Okay? I will give anybody 10 extra credit quiz points if they will find me a real way to do this in Microsoft Excel. Now, apparently there is a way to do this there's a programming language called R. It's actually free, but I try, you guys are struggling enough with Excel, I don't want to make you learn how to program. Okay? If you can find me an Excel method for doing this, to create those, I gave this offer last semester and somebody gave me something and it wasn't very good. Okay? I didn't even know how to do it. So it's like, oh yeah, here's a YouTube video. Sucked. So, I'll give that's your opportunity. But as you look on page, well, I've given you some homework. One of the nice things about the homework is, if you look at these, see that looks like the same one right here, doesn't it? Can I click on that? Is that the same graph? No, it's a little different. Looks like it though. Obviously that's a bad example. One of the nice things about the computer, or about this book, is it gives you those lines, so it makes it really easy. I don't know how to create them, okay? So the quiz tomorrow is basically going to be on, can you read a QQ plot? I won't make you make one. I'll save that for the test in 3 weeks when you've forgotten. Okay? So, would anybody like to create a QQ plot with a new set of data? So who wants to do really well on the test? Who wants to volunteer to create a QQ plot? Ashley? Okay. All right. So before you come up, so I've got another one here on waiting time. Okay? You can come up if you want. I was going to save you a little bit here. So this wasn't very nice data. So here's what I'm going to do. I'm going to copy this. Okay, I'll show you guys how to do this. Okay? And then I'm going to right click and you can do a thing called transpose it. So I went from a bunch of rows to a bunch of columns. And then I'm going to put all of these in a single column. Well, maybe I should let Ashley. Do you want to do the rest of them?
No, you got it. Great.
Okay, so you can ignore the beginning. Here's your data. What are you supposed to do?
First thing would be to sort it.
Okay, and that's the part you're not going to forget, right, Katie? You're not going to forget to sort your data? Okay.
How did you get it to transpose?
So if you right click it, so have you copied it already? Oh, I don't know what you're doing. Oops, sorry. Highlight everything. Yeah, you were, I don't know what
So,
you're doing.
and then you go down like.
Copy that and then
then
transpose.
right
Okay,
click.
so actually
And
click,
then- so
highlight the
that
1, 2,
little
3,
arrow, so one, yeah, that was good, yeah.
double
Buildings
click
winning.
on the little
I saw
square
that.
thing. No, higher.
Oh,
Yeah.
where?
That little corner, the corner, tiny little square by the 3 corner, yeah, there you go, double click. Okay? Isn't that nice? Count to 100 just like that.
Wizardry.
Okay, make sure it goes to 100 at the bottom. Okay, 100 data points. Okay? All right, is she going too fast?
Yeah.
You slow down.
I put the video
Can
in
you make
this.
it bigger?
Can you make it bigger? Do you know how to do that? Yeah, plus, there you go. All right. You caught up?
No.
No? What are we waiting for? Renee got a bunch of threes. So you gotta highlight, there we go. She copied a bunch of threes down, because you only have that as one cell. Okay? Are we good? Okay, so we're gonna do F sub I, which is our probability. Okay, equals index minus, not underscore, minus 0.375 divided by 100.25. You got 100 data points, right? Ashley's gonna ace the test. Okay? Double click. Is she going too fast? Would you slow down?
That's the probability, right?
Okay, so that's the probability, yes. The probability if it were normal. Okay? Okay, now you can speed up because we only got 1 minute left. Okay, z-score, and by the way, I've already posted this, so it's already there. If you go to the one below, it says worked out already. You're doing it for nothing? It's good practice, it's not for nothing. Norm S inverse, okay? The one without periods is slightly easier to use. Click on that, press enter, copy it down, copy and paste. Who learned that new cool trick today that didn't know it before?
What trick?
To double click in the little corner there, okay?
Number 100.
Could have used that on the last test, huh?
Teach that in the first
I did teach that.
The 100th point.
Okay?
Wait, what does N stand for? We did the
And is your sample size. So we've got 100 data points. Okay? All right, so now finally, before Coy leaves,
How do I select both? Because I'm trying to
okay, so hold, so the first column, you hold the control key down, and then select the fourth column. Okay, not like that, no, you just, okay, let's try it again. Select the data column. For those of you who have really good vision.
Sorry.
I can see your shirt.
Okay,
is fine.
now hold the control key down, sorry. Oh, let me show you again. Hopefully that's not a problem, we'll see. We're just about to find out. Insert your scatter plot. Okay, make it a little bigger so you can see it. Look at our scatter plot. What do you think about that scatter plot? Does that look normally distributed?
No.
No, way too curvy. Okay, notice that was 100. So 30 does not give you a free pass to assume it's normal. Okay? Megan.
Also saying.
Okay, you gonna use the test?
How long did it be? I got a B. What did you get? Girl. Oh yeah.
You grab the data screen.
Yeah.
I always thought this was more highlighted.
Good. Go forth and prosper.